All right, let me fill you in on where we're going today before I let you and your group do your thing. Last Monday, already went over. Last Monday, we got two theorems. All right, the exterior angle one and biggest side across from biggest angle. There's one more I need you to know, and that's what we're going to work on today. So there's three total in this unit, the two we went over last Monday, and one we're going to do right now. And this one we're going to show you today. I'm not going to give it to you. You're actually going to figure it out in your groups. Is when you have a triangle, believe it or not, you can't have any three side lengths you want. Like if I have 3, 10, 100, it's not going to work. It's not going to work. You cannot have three side lengths, any three you want. It's got to follow a specific rule. And that rule, you're in charge of finding it in your groups today. All right. What has to be so great about the three sides of a triangle to actually form a darn triangle? Okay, so that's what you and your groups are going to investigate today. Now, you'll see in the directions, each member of the group should take turns picking 3 straws. Straws. Come on now. As I ask you all the time, and some of you guys really get depressed when I ask you this, what class are we in? Honors, right? Straws. Straws in an honors class. Are you kidding me? No, instead of straws, we're going to be using strips of licorice today. So please act like you've seen food before. All right, no savages or animals. I am going to give you and your group some strips of licorice. What you're going to do first is you're going to create 2, 3, 4, 5, and 6-inch pieces of licorice for me. All right, so actually measure them out. How you cut them, that's not my problem. Okay, that's on you and your group. That's all I want you to do first. Please do not move ahead. So when I give you your licorice, don't eat anything. Cut them up into 2, 3, 4, 5, and 6-inch pieces. That's all I need you to do. Once I see everyone's got that, I'll tell you your next job. All right? Here we go. Let's get to work.
Wait, who's doing what? Charlie, you want to do 2? I'll do the 6.
If anybody needs extra, because I didn't give you enough, let me know.
I did the 6 and 2. What? 6, 5, 4. Oh, my protractor?
That's all I need are those pieces. And then I'll tell you your next job.
We're doing 1 for each. 3, 5. We'll do 2 and 3. You guys do 4.
If you need more, let me know. Add more.
Alright, you do 3, I'll do 4.
Go with 8 inches.
But someone has to do 6 inches. Then who's doing 3?
This is almost 3
What are you?
I'm doing 2 right? Wait, no, I'm doing 6. So, Thor, you're doing 3? Alright, I'll do 4 then.
So, you guys have 3.
Make sure you keep track of how long each piece is, because you'll need to know that.
We'll do 3 and 4.
Yeah. Here, this is 4. So this is 2.
Okay, let's make 4.
Alright, so then put the 3 next to it.
3.
Here's the 4.
6 and 3.
And Doyle, you have the 6.
Oh, I said how perfect, but like I don't want anything that's touching the paper.
Okay, everyone's got their strips. All right, next job. Remember, we're trying to find this rule that I can't have 3 sides, that the 3 sides have to fall into a certain rule. Next step, pick three. Pick three of your strips. Write down their lengths here in your table. And then see if you can put them together to form a triangle. Now, whoa, what do I mean by form a triangle? No extra exterior angles. All right, that won't work. All right, I need them to touch. If it comes up short, not a triangle. All right, I need you to find, here's your goal, 3 sets that do form a triangle, 2 sets that do not. That is your goal right now. So go ahead, take 3, write them down. If it's controversial, call me over and I'll settle it. But I need 3 that do, 2 sets that do not. Okay, so record your lengths, see if they form a triangle. If it's controversial, let me know. I'll settle it.
So 2, 3, 4.
3 sets that do, 2 sets that do not.
All right, give me like 3 and 4. Give me 3 and 4.
Form a triangle.
What's the one that's
3 sets that form a triangle, 2 sets that do not.
Where's 6? Yeah, that's not working. Try 6, 5, 8. I thought 6, 5, 8.
What's the biggest one? Wait, if they're equal, that's 2, 6, 5, and 2. What was the next one you wrote down? 6, 4.
2, 4, 3.
It's definitely
5, 6, 8.
No, it's a, we need 3 yeses, so we can't have it. Right? Yeah, 3.
So go like 2, 6, 5, 6, 2.
We already did 2, 3, 4, 6. We already did 2, 3.
Let's do 6, 3, or 6, 3, 2.
I think it's all the sides of Patterson.
That works.
2, 6, that's 2, 6.
Add in, add it.
Wait, which one doesn't work?
This is 8.
2, 4, 6 doesn't work.
We have to have one more yes.
I think all the triangles.
6, 2, 5.
So how many
2, 4, 5.
That can be.
Really need to find 3.
That work, 2 that do not work.
Okay, we need
3 sets that work, 2 sets that do not
I
work.
guess that works. So 2.
3.
I mean, they're kind of dead. It was like 2 cents.
Is that there?
It doesn't really matter what I pick.
More than that.
Where do we go?
5, 4, 3.
No, that's 2, 3, 4. Oh, that's 3.
5, 4, 3. Yeah.
And then obviously, if you want to see like all like things, has to be the front one.
So I think it's
So we gotta filter my boxes.
do we? Or do we just have to get to it?
This makes sense.
Yes, it does.
How's every group doing? All
We have
right?
to fill all the boxes.
No, I want 3 sets that do, 2 sets that do not. So just 5.
That was just extra space.
Just so you guys can see the pattern.
Yeah, like 6, 7, 6.
Wait, so then dad's one. Yeah, I'm realizing that right now.
I don't know how to say that. I don't think it was.
All right, here we go. Before we get to our final job, let's go around to every group now. First, give me a set of 3 that did form a triangle. This first group up here, a set of 3 that did form a triangle.
2, 4.
2, 3, 4, yes. 2, 3, 4 was a yes. Group back there, another set that gave me a yes. 5, 4, 3, 4, 5. Yep. 3, 4, 5 was a yes. And one more yes. Group in the back here.
3, 4, 6.
3, 4, 6 is good. Yep. All right, let's go to the nose now. Give me 2 no's here. Nose. Group up here, a no.
2, 4, 6.
Yeah, that was a no. And then how about one more no here?
2, 3, 6. Do we have 2, 3, 6?
2, 3, 6 I do not have. And I don't know if where you put this one, but I'm just going to add this up here as a third one. 2, 3, 5 should not have worked either. 2, 3, 5 was a no. I don't know if anybody had that in the yes category, but that was a no. All right, so we have a pattern here. All right, there is a rule the sides must follow in order to form an actual triangle. All right, as you guys can see, just by these 3 sets right here, not all numbers work. So I'm going to give you about a minute, 2 minutes to go back into your group and say, all 3 sides have to do this to form a triangle. Okay, here's the rule. If you give me 3 sides, here's how I can figure out if it's a triangle or not using the ones that you've come up with on your own. So go ahead, talk it over with your group, and we will officially write down a theorem after. So if I give you any 3 sides, here's how you and your group would figure out if it's going to form a triangle or not going forward. Okay?
I would say.
What rules do they have to follow?
Is it like number 1 plus number 2 is 1 greater than number 3?
Is there?
One of them is
Oh, yeah. I got
So one of them must be so one of them has to be must be greater.
I studied so hard for the last one. I still did so bad.
So one of the sides must be
No, you're right.
Okay, let's talk here. Let's talk. Let's talk in your own words, and then I'll put something official where it says triangle inequality theorem down in your text box there. For any group want to, if I give you all 3 sides, here's how you can figure out if it will form a triangle or not. You're gonna go, Matt?
The 2 smaller sides have to add up to more than the bigger side.
Correct. All right, and it's just got to be more. It has to be any 2 sides. All right. If you pick any 2 sides, so for instance, 3 and 4, any 2 sides added up have to be greater than the 3rd side. Now, the way you can tell right away is what Matt said, which is, all right, you find the 2 smaller sides, and when I add them up, if they're automatically bigger than the 3rd, you don't need to try out the rest. Okay, so any 2 sides bigger than the 3rd. Why didn't it work down below? Well, you know about 2 and 4, they add to 6. It's got to be greater than, not greater than or equal to. All right, so let's write that down officially now in the theorem box there. The triangle inequality theorem in a triangle. Sum, which means I'm going to add them. Sum of 2 sides must be greater than the 3rd. What is that? Okay, greater than, not greater than or equal to, greater than. All right. So there's your 3rd triangle theorem there, along with the 2 we did last week. All right, numbers coming out now. Calling on individual people. All right, so what I did here, 1 through 5, I'm giving you the side lengths. Will it form a triangle or not? If it's a yes, just tell me yes. If it's a no, tell me why. Okay, so if I had a triangle that had 3 sides of 1, 2, and 3, would that form a triangle or not based on our new theorem? Oh, Charlie, right off the bat, yes or no?
No.
That'd be a no. Why not?
So it's 1 and 2 don't add up to be greater than 3.
Correct. And all I need is one example that it doesn't work. I know people, well, wait a second. 3 plus 2 is bigger than the 3rd side. I know, but it just takes one no. Okay, one way it doesn't work. 2, 4, 5, would that form a triangle? Kind of just already had that one. 8 and form a triangle?
Yes.
Yes, it would. Yep. How about 5, 5, 6? 5, 5, 6, form a triangle. 9, Ian?
Yeah.
Yes, and everybody else for a little extra bonus. What type of triangle is that? Isosceles. There you go, Josh. Yeah. 8, 13, 21. Going to form a triangle. 7, Amy?
No.
Nope, why not?
The length of the two short sides is equal to the length of the longest side.
Got to be greater than 21, not equal to it. 10, 20, and 25. What are we looking at there? 2. Zoe? Yes. That would work. And that's all you guys have, right? All right. So you can tell me if it's going to form a triangle or not. Last thing I need you to do is, if I give you 2 out of the 3 sides, can you tell me possible values of the third side? All right. So I know one side's 4 inches. The other side is 7 inches. What are possible values of the third side? Now, I don't want you to just list out the numbers. All right. I don't want you to list them out. What I want this answer in is in the form of a, I know you guys probably did them last year, I hope, in Algebra 1, called a compound inequality, where you have 2 of those inequality symbols. So x is greater than this number, but less than this one. All right, so that's what I need your help finding. That third side has to be greater than this, but less than this. So the way we're going to figure that out is, for the first and last time, I don't actually want to list out the possibilities down here. All right, and then hopefully once you see the possibilities, you can help me fill in what it has to be greater than, what it has to be less than. So anybody would just want to start by throwing out, obviously don't just throw out any side. You give me 20, that's not going to fall into our rule today. That doesn't work. It's got to be a specific side length that'll fit. So if I start with 4 and 7, the third side could be, anybody want to start us off? Start us off, start us off. Third side could be, Doyle, 12? Would 12 work? Is 12 going to work before I write it down? Sum of 2 sides needs to be greater than the third. If I write 12, Doyle, 4 and 7 give me 11, not greater than the third, right? So at least we know it can't be 12, 13, 14, right? I don't want to keep going there. You want redemption?
Yeah, it'd be 10.
Okay, 10, good, yeah. Why don't I want to write down 11? 4 plus 7 is 11. It's got to be greater. So at least we know I'm not writing anything bigger than 10 now. Any others going other way before we start finding the pattern? We can write all of them in pretty quickly. Other values it could be. Could be 10. Also could be, what do we have?
9.
It could be 9. All right, here we go. You want to go 8. We can go 7. When does this train end? Could we go 6? 6, okay? Could we go 5? Could we go 4? 4? Can we go 3? No, good. 3 plus 4 is 7. It's got to be greater. So it looks like 4 to 10, right? Don't write this on your paper, though. Don't write it on this on your paper. It includes 4, right? It includes 10. So what? Anybody remember what you have to put here? Don't write it down, though. What do you have to put here? Remember the or equal to's? I still don't like it. It's not good enough for me. It's not good enough. You want to know why it's not good enough? Would 10.1 work? 10.1 work? Yes, but it's not included in your inequality. It's 3.9 work. If I put 3.9 here, would that still work? It's not in your inequality though, because you stopped at 4. Talk it over in your group. How can you change my inequality so it would work? I'm going to get rid of the numbers. Talk to your group, because 3.9 and 10.9 is not, 10.1 is not in there. I need something where it's included.
Well, it's less than 11. Anything less than
I used to do like just write 10 as inequality and less than x is less than y. So it includes like everything that's like 3.1.
Any group have a solution to my issue? What's up, dude?
3. is less than X. But, yeah, X is less than.
Should I put the or equal to? I like that a lot better. Because now that has 3.1, 3.2, 10.9, 10.8, 10.6. That looks good to me. Now, I didn't keep track of time, but that took us a while to do that. All right. And what's going to happen now when my sides become further apart? Like what happens when that's a 40, that becomes 40 and that becomes 70? Am I going to really realistically ask you guys to list down everything and then plop those boundaries in? Probably not. That's way too long. Way too long. So maybe, is there a quicker way I can go from the two sides you're given to what the third side has to be between? Look at our example we just did here. I gave you 7 and 4, and look at, we said, that third side's got to be somewhere between 3 and 11. So can I get to those two sides a little bit quicker now? Anybody see what I can do to 4 and 7 to get to 3 and 11 in?
You can add them and then subtract.
Add and subtract them. I don't like to say it's a trick, but that's the quicker way. Instead of listing out every single side it could be, that's the quicker way to get to the boundaries, 3 and 11. All right, so using that right now on the next problem, 9 and 17, instead of trying to list all the sides it could possibly be, I can just say, all right, well, it has to be somewhere between 17 minus 9, 8, but less than 17 plus 9, 26. A little bit quicker than listing out all the numbers between 8 and 26, right? And then now I'll call on somebody. Now if I have 11 and 20 for problem 4, those three sides have to be between. Good thing we don't have to list this out. This would have taken forever to list those out. Has to be between what, Matt? Has to be greater than 9, but less than 31. Whew. See what I mean by having to list those out? That would be a while. Any questions from you guys? So now you have 3 triangle inequality facts. 3. You do what you want with the licorice. If you guys want to eat them, eat them. If not, toss them in the garbage. That's fine too. Just don't leave them on the desk or the floor. Put all your straight edges that are mine in the middle. I'll come around and collect them. And then you guys get started on the assignment. Probably could finish it by the time you leave here today. All right, you have 15 minutes left.